Hello, everybody. We are starting Unit 3, and the first couple lessons start off with some material that, for the most part, you should have seen before. There might be a couple things that maybe it's been a while or you don't quite remember, but it's solving equations. And we spend a lot of time in Algebra 1 solving equations, and you solve equations now in Algebra 2. So, remember, the goal is to get the variable alone. So that means we have to undo whatever is being done to the variable. So if we're adding something to x, we have to subtract something. If we're multiplying something to x, we need to divide. And whatever you do to one side, you must do to the other side. We have to do the same thing to both sides of the equal sign. So, steps to solve. First, distribute. If it's possible to distribute, we're going to distribute. Second is to clear fractions or decimals. And we'll show you how to do that once we get to some examples here. Step 3 is combine like terms. And I'm going to put a note that are on the same side. Step 4 is to get variable on one side. Step 5 is to undo addition or subtraction. Last step is to undo multiplication or division. All right, one more thing. We sometimes have identities or contradictions. Identities are things that are always true. Contradiction are things that are never true. And these occur when the variables cancel out. And if the variables cancel out and the constants are equal, so like we're left with 5 equals 5, or 7 equals 7, -2 equals -2. That means our solution is all real numbers because it's always true. If the variables cancel out and the constants are not equal, so if I get 0 equals 3 or -5 equals 4, those two things do not equal each other. So what that means is we have no solution. It's never true. So again, like I said, most of this stuff is stuff that you should have seen before, but we're just kind of recapping it here. Go ahead and pause the video if you need to get all this stuff written down. I'm going to move on to example 1. Okay, step 1 is to distribute. No distributing needs to happen. No fractions or decimals. No like terms that are on the same side. However, I do have a variable on both sides, so I want to get the variable on one side only. So I'm going to subtract 3r from both sides. Those zero out. We're left with 3r equals -12. 6 minus 3 gives me 3r. What's being done to my variable? Well, the only thing that's being done to my variable is multiplication. So I undo that by dividing both sides by 3. Those 1 out, and I'm left with r equals -4. Okay, example 2. No distributing. We do have a fraction. So how do I get rid of this fraction? Well, the way that you get rid of a fraction, so to clear a fraction, multiply every term by the denominator. To clear a fraction, multiply every term by the denominator. So in this case, the denominator of the fraction is 3. So I'm going to multiply everything by 3. 3 times 18, we're going to distribute now. 3 times 18, 54. And now here's why this works really nicely. When I do 3 times 2/3, all I'm going to be left with is 2. 3 times 2/3 is just 2. So I have 2f. 3 times 12 is 36. And now this is nice because I don't have to deal with any fractions. I have to get rid of this 54. I want to zero it out, so I'm going to subtract 54. And be careful because sometimes I see students want to add 54 because they see this minus here. But what you have to remember is that this minus is attached to the 2, not the 54. So if I want that to be 0, I have to subtract 54. 36 minus 54 is -18. Then we divide by -2. Those 1 out. F equals 9. All right, example 3. Distribute. 2 times 3t is 6t. 2 times 4 is 8. No fractions or decimals. No like terms to combine. I do need to get the variable on one side. So I'm going to subtract 6t from both sides. That zeroes out, but so does this over here. And I'm left with -8 equals 3. All right, this is what we got going on here. Our variables canceled out, but our constants are not equal. -8 does not equal 3, so this is no solution. There is no value of t that will make the equation true. All right, moving on. Example 4. We're going to distribute. 3/5 times a is 3/5 a. 3/5 times 1 is 3/5 because anything times 1 is itself. I do want to clear the fraction, so I'm going to multiply everything by the denominator, which is 5. And just like when we did 3 times 2/3 and we were left with 2, if I do 5 times 3/5, I'm going to be left with 3. So 5 times 3/5 gives me 3a. Again, 5 times 3/5 is 3. But I also have to do it on this side. I have to multiply every term. So I have 5a. 5 times 3 is 15. Okay, now no like terms. I do want to get the variable on one side. I like to keep my variables positive, so I'm going to subtract 3a instead of 5a. Then I'm going to subtract 15 from both sides, which gives me negative 18 equals 2a. Divide both sides by 2. We get negative 9 equals a. Oops. Okay. Number 5, going to distribute. 1.5 times 2 is 3. Now, you don't have to clear the decimal, just like you don't have to clear a fraction. But if you want to clear a decimal, we multiply everything by 10. If you do 10 times 1.5, you're going to get 15. 10 times 3 is 30, and 10 times 7.5 is 75. Now, you might be thinking, it would have just been easier to leave it as the original equation. And if that's what you think, then that's totally fine. You do not have to clear anything out. It's just sometimes people like to work with whole numbers instead of decimals and fractions. And if that's you, then this is a trick or a strategy you can use. All right, I'm going to divide by 15. And we get x equals 3. All right, example 6. We need to distribute on both sides. 2 times 5x is 10x. 2 times 3 is 6. Then I have that minus x there. 3 times 3x is 9x. 3 times 2 is 6. I have like terms, so I have 9x minus 6 equals 9x minus 6. I need to get the variable all on one side. We have variables canceling out on both sides. But I'm left with constants that do equal each other, which means the answer is all real numbers. So what that means is that x can equal any number, and it will make the equation true. All right, flipping the page. I would like you to pause the video and try examples 7 and 8 on your own. Examples 7 and 8 on your own. So pause the video, try these on your own. All right, you should have gotten t equals 0 for 7 and no solution for 8. One thing that I see sometimes is students get confused with the fact that they get 0, but the variables don't cancel out. 0 is still a possible solution. So that's just something to think about. All right. What the heck do I do with this big fraction here? Well, I'm going to clear this fraction. I'm going to clear the whole thing. So if I multiply both sides by 3, what happens is 3 times something divided by 3, these basically just cancel out, and I'm left with 6x minus 2 times x minus 4, and then I do need to do 8 times 3 here, and we get 24. And then you can solve it just like normal. So I'm going to distribute negative 2x. That gives me 4x plus 8 equals 24. Subtract 8 from both sides. Divide by 4. We get x equals 4. All right, number 10. Tell whether each number to the right of the equation is a solution to the equation. So if it's a solution, it's going to make the equation true. So I have to check to see if 0 is a solution or if negative 1 is a solution. So what that means is I'm going to go through and I'm going to replace every x with 0. And then I'm going to replace every x with -1. So if x is 0, I have 0 plus 6 over 2 times 0 minus 3 equals 0 minus 2. And what I'm going to do is I'm going to simplify it to see if we end up with something that is a true statement. So on the top, 0 plus 6 gives me 6. 2 times 0 is 0, minus 3 is -3. And 0 minus 2 is -2. And 6 divided by -3 is -2. So that is true. That works out. So that means x equals 0 is a solution. It is a solution. Now let's check -1. I'm going to do the same thing. It's just now I'm going to make every x -1. Okay. -1 plus 6 is 5. 2 times -1 is -2. Minus 3 is -5. -1 minus 2 is -3. 5 divided by -5 is -1. That does not equal each other. So x equals -1 is not a solution. All right, last thing here, proportions. To solve proportions, we cross multiply. So when you see a fraction equal to another fraction, you simply multiply the numerator of one by the denominator of the other. So I'm going to do 16 times 70, which is 1,120. 40 times x is 40x. So I'm going to divide by 40. We get 28 equals x. It's as easy as that. Now, you do have to be careful when you have something like this. So I'm going to do the same thing. I'm going to cross multiply. 5 times 15 is 75. And when I do 6 times x plus 2, you have to remember that I'm doing 6 times that whole thing, not just this. If you write this, that's wrong. It has to be 6 times the whole quantity x plus 2, because now I'm going to distribute and I'm going to actually have 6x plus 12. So if you wrote 6x plus 2, you would actually end up with the wrong answer. So you have to be very careful there. I'm going to subtract 12 from both sides. That gives me 63. Divide by 6. And that gives me 10.5. All right, that is it for the 3.1 notes. You are going to complete the 3.1 homework, which is on pages 3 and 4. So you are going to do everything numbers 1 through 18. Thanks for watching, and we'll see you for 3.2 in the next video.